My name is Mark Cruz. I'm a computer researching scientist. I recently just passed the Cisco Certified Network Associate exam. I couldn't think of a better way to celebrate passing the CCNA exam than to do some configurations on the Cisco Modeling Lab platform. So what we're going to do is we're going to start a virtual machine that will act as our Cisco Modeling Lab server. We'll connect to this virtual machine server with the IP address 192.168.1.92. When I configured the virtual machine server, I configured it to get its IP address with DHCP, so it pulled its IP address from my local area network router, so that way I could use my computer to access this web interface through a web browser. So what I've done here is I've put in 192.168.1.92 into a web browser, and now we're taken to the Cisco Modeling Lab platform. This is the topology we're going to build in the video. First, we'll start with these bottom two local area networks. Then we'll move on to this left side of the network where we'll do some DHCP configuration stuff, and then finish off the video with some hot swap routing protocol right before it exits to a layer 3 switch that represents the internet service provider. So the idea is that's your exit gateway. That blue router there is your gateway to the internet. I was using a Surface Book 2 when I used the Cisco Modeling Lab platform. It's got 16 gigabytes of RAM and an Intel Core i7. These topologies are saved as YAML files, known as YAML files. So when you build your topologies, they're stored, in this case, on our virtual machine. But if that were to fail for whatever reason, we would lose our topologies. So the platform has a feature where we can download the lab in a YAML file, which is the .yaml file type. This allows us to back up our topologies and share them with other people. After we click on the Download Lab button and we navigate to our Downloads folder, we can see that the topology was saved in the .yaml file format. So we're going to delete this YAML file, and then we're actually going to go into the Cisco Modeling Lab platform and delete the topology. So now we've completely lost the topology. But what I've done is I've uploaded the YAML file to my GitHub account. In the repository, there's also text files with all of the configuration commands throughout the video. This way you can download the YAML file, import the YAML file into the Cisco Modeling platform, and then copy and paste the configurations from the text file into the Cisco Modeling Lab platform. Or you can also follow along with the video and just have the commands there as a reference in the text file. So we downloaded it as a zip file from the repository, and then we'll drag the YAML file out onto the desktop. I'll open a few of the text files to show the different commands that are used in the configurations. What you will do is copy and paste from the text file into the console of the virtual machines in the Cisco Modeling Lab platform. Now we've come back to the Cisco Modeling Lab platform, and there's that import button in the upper right hand corner of the web browser. So when we click on this import button, it'll take us to a page where it will ask us which files do we want to import. Since we dragged our YAML file to the desktop, we'll look on the desktop, find the YAML file, double click on it, and then click on the import button. And now the topology has been loaded back into the Cisco Modeling Lab platform. And there it is. So what I did is I used GitHub to both back up and share these network topologies and configurations. The neat thing about this platform is you can save topologies. So for example, here I've got a topology that I used when I was studying for the exam to help me better understand OSPF designated router elections. So then I could just have that topology built in there and turn it on whenever I need it. But in this video, we're going to be building that whole big topology from scratch. This is how the interface works. There's a tray of different networking virtual machines that we can load into our topology area. And we're going to build everything with these three devices, a router, a switch, and a desktop. So this is going to be the start of our large topology. It's going to be this first local area network. And what I like to do is I drag out all of the virtual machine devices that we're going to be using, and then make the connections, label everything before I even turn on any of the devices. I found that if you use really good labeling on the setup, it makes the labs a lot more fun and less cumbersome. In this particular local area network, we're going to have 8 desktops, 4 switches, 2 of which will utilize layer 3 technologies, and then 1 router. So right now I'm just kind of setting up how I want the topology to look like. You can make this however you want it to be. And we'll pretty much just be mimicking this topology. And the neat thing about the Cisco Modeling Lab platform is you have these different tabs that you can utilize on the virtual machines. One of them is connectivity and allows me to see which port is connected to which port. And with everything properly labeled, you can see how much easier it is to determine the devices that you'll be working on. So the first thing I do is I go in here and I start labeling the devices. The top router will be central. This first switch will be dist 1. The second switch will be dist 2. And then the bottom 2 switches will be access switches. So this lower left one will be access 1. And the one on the right will be access 2. So for this topology, each of these desktops will be placed in their own VLAN. So I went ahead and labeled each desktop with the respective VLAN that it will be placed in when we start doing our configurations. So after we finish all of our labeling, we're going to start making our connections between the devices. So now that we've finished our labeling, we're going to get into making the connections between the different virtual machines. This particular GUI interface that the Cisco Modeling Lab uses works really well when making these connections between the virtual machines. When you see after proper labeling, it actually labels the column header with the name of the virtual machine, and then a drop-down list of the port that you want to select. You're also allowed to add interfaces to the virtual machines. When the configurations have not been done yet, you can go into the virtual machine and add interfaces to the device. This first part of the topology is going to be a layer 2 ether channel. So what I'm doing here is I'm making 4 Ethernet connections between these two switches so that I can create the ether channel between them. So this is just, I haven't turned on any of the devices. We're just making, it's the equivalent of plugging the cable into the device. So we'll also have a point-to-point connection between this layer 3 switch and the router. We'll have to turn the ports into routed ports, but we'll get into that later into the configuration process. For now, we'll focus on just making the connections here. Between disk 1 and disk 2, we're going to have a layer 3 ether channel. So again, we're going to have 4 Ethernet connections between disk 1 and disk 2. So what we're doing with this other half of the topology on the right here is we're going to do a traditional router on a stick configuration, which means there's only one link between the layer 3 switch and the layer 2 switch that acts as a trunk link to then allow the different VLANs to have tag traffic flow across the trunk link, so then that the layer 3 switch can do routing between the VLANs, and that's kind of what routing on a stick is referred to as. So the last piece for us here is we're just going to tie in our connections from our access switch to our PCs. And then this is our first local area network topology that we'll be working with. And now that we've made our connections, labeled everything properly, we can start turning on the devices. Later in the video, we'll see that depending on which license you purchased, you can only have so many nodes operating in your topology at one time. So the desktops provided with the Cisco modeling labs are configured to pull IP addresses with by DHCP. You can also configure them statically by editing the startup configuration. Essentially, what these desktops are, they are Alpine Linux boxes. So they actually use a Linux operating system. So here I just have 2 Linux commands to set the default gateway for the desktop, and then the IP address of the desktop statically. The default gateway command is that route add default GW, the gateway IP address, ETHO for Ethernet 0, and then the static IP address command is IPADDR add the IP address with the subnet mask dev and then ETH0. And then all you have to do is change the default gateway and the IP address for each machine, and then you can just copy and paste the configuration to each virtual machine. The other thing to be careful when you do this, you have to click that save button there right on the upper left of the notepad. If you don't click save, then it will revert to the default and will not save the startup configuration. So you have to click save whenever you edit these startup configurations. So now I'm going to go into each desktop and statically assign the IP and the default gateway. So now we're ready to turn on our devices. So we start by turning on disk 1, disk 2, access 1, and access 2. With smaller topologies like this, the performance is excellent. The devices, their startup configurations load very quickly. As the topology grows and we add more virtual machine devices to the topology, the performance of the Cisco Modeling Lab platform starts to suffer a little bit. The loading times, for example, when you start new devices is much longer when you have 20 nodes as compared to just these 4. Thank you for watching.